Today we're going to be talking about factoring trinomials in standard form. What is standard form? This right here, ax squared plus bx plus c. So when is this method used? When a trinomial, remember tri is 3, so a trinomial in standard form again is ax squared plus bx plus c, has an a term that's not 1 or negative 1. That's not 1 or negative 1. Okay, let me make this clear too. So the a term is not 1 or negative 1, okay? Now let's look at this first practice example. You see how this a term, this is the ax squared, is not 1 or negative 1. It's a 3, right? So this is when we have to use this method. But if it was a 1, let's say it was 1x squared plus 16x plus 21, okay? Let's say it was 1. We still can use this method. It's just quicker to use the method that we used last week. So remember when after we did the x last week, we multiplied a number up here, and then we did another number over here, and then remember we jumped straight into the factored form, like x minus 3, x plus 2. We can't do that when the leading coefficient, which is the a term, when this term is anything other than 1. We can't just jump into it. We have to do a couple more steps. But we can always do this method for any form, even if this is a 1 or negative 1. It's just quicker to do the method we did last week. Okay, so here's the rules. The first step is to identify A, B, and C. So we have an example up here. You can look at that one if you want, but I'm going to do the first one with you, and I'm going to do step 1 first. So identify A, B, and C is the first step. So A is 3, B is 16, and C is 21. The second step that it tells me to do is to multiply A times C, right? So right here, multiply A times C and some number that adds to B. So it has to multiply to A times C and add to B. So let's do A times C. A times C, 3 times 21. That's going to be 63. And it has to add to 16. So this is A times C. This up here is A times C, and that was 3 times 21, and this term is B. Okay, so now we have to find, so that was step 2. Step 3 here says find the factors of A times C. So we're going to find the factors of this number, whatever's up here, your A times C. So we have to find the factors of 63. So I'm going to do it down here. 63. Okay, well, we have 9 times 7, and that adds up to 16, so we can just jump straight into that. 9 times 7 is 63, and 9 plus 7 is 16. So from this point, we're going to go to our fourth step, and notice what is in this box, and this box stays the same. So what number is in this box? This is your ax squared term. This is your first term. The one down here is your c, okay? So our ax squared term is 3x squared. I'm going to write that right here. And my c term is 21. So I'm going to write that down here. Okay, so this is where this part comes in. You see this 9 and 7. 9 times 7 is 63. 9 plus 7 is 16. So those are our two numbers. But we're going to put them, it doesn't matter which order. We're going to put them here and here. It doesn't matter. I could have put the 7 where the 9 is, or the 9. It doesn't matter which way. But we can't forget that those two numbers have to add up to our middle number, so we have to give them an x. Because 9x plus 7x, if we add those two up, it has to equal this middle term still. So make sure you put an x always, or whatever variable you're using. Okay, so now we're going to take the GCF. So we're going to look at each piece. First, I'm going to look at just these two. What is my greatest common factor? What do they have in common? So 3 and 7 have no numbers in common, so I can't take out a 3 or 2 or 7 or anything like that. But x and x squared, I can take out an x. Whatever your GCF is for these two boxes, you're going to put it up here. So my GCF is an x, so I'm going to write x up here. Okay, I just pulled out an x, so I said my GCF of these two are an x. What about my GCF of these two? What's my greatest common factors? Well, 3 can go into both of these, right? That's the highest, that's the greatest that it can be, a positive 3. So I'm going to write positive 3. And then I'm going to go on this side. So between these two numbers, and I'm going to write it over here. So it goes in a straight line. This GCF goes up here, this GCF goes here, this GCF goes here. So what's my greatest common factor? They have numbers in common? They do, they have a 3 in common. So I'm going to write 3. And then what about the x's? What else do they have in common? They have an x, right? They just have one x. And then on the bottom here, 7x and 21, what do those have in common? They have a 7, right? I can divide this by 7, I can divide this by 7. So I'm going to write a 7, but they both don't have an x, so I can't write x. Okay, and it's a positive 7, so I'm going to write a positive 7. And you'll see why I write that for the second term in just a second. So now we're finished factoring. Watch what we can do. We can take this piece, x plus 3, and we can take this piece, 3x plus 7, and that's our answer. Now, if we FOIL this, remember, just like it's first, outer, inner, last distribution, 3 times x, or x times 3x, I'm sorry, x times 3x, that's 3x squared. That's this piece, right? We got, okay, 3x squared. We're supposed to get 3x squared plus 16x plus 21. 7 times x is 7x. 3 times 3x is 9x. Well, 7x plus 9x is 16x. And then 3 times 7 is 21. So we got the same thing. So that should happen when we multiply back. We should always get our original trinomial. And that's the answer. So let's try another one. So first, identify A, B, and C. So A equals 5, B equals 6, and C equals 1. Again, you have to use this method when the A term is anything other than 1. But if it was a 1, you can still use this method. Okay? So let's multiply A times C up here, A times C, and that's 5 times 1, so that's just 5. And your B term is down here, which is 6. So we need to find the factors of this number. So factors of 5, well, that's easy, just 1 times 5, right? So we know it has to be 1 and 5. 1 times 5 is 5, and 1 plus 5 is 6. So we have our two numbers. That's what we need, 1 and 5, okay? So now we're going to write in our A term, ax squared, which is 3x squared. No, it's not. Sorry, it's 5x squared. So 5x squared. And our C term is 1. And then we have to take these two numbers and put them, it doesn't matter which order. And then remember, we have to give them an x because they have to add up to this middle term. We're not changing anything. So we have to give both of them an x. We don't want to change anything. Okay, so now we're going to factor it. So we're going to pull out a GCF from each of these pieces. So let's look here. So remember, we go straight in a straight line. So we're going to pull the GCF, we're going to put it up here. So 5 and 5, what GCF do those have in common? Well, 5, right? And then what about x and x squared? Just an x. I can pull out an x from both of those. What about 1x and 1? Well, the only GCF I can pull out of that is just a 1. So I'm going to put a positive 1. And then from 5 and 1, there's no factors that can come out except for 1. But what about x squared and x? So we can pull out an x from those two. And then 5x and 1, we can pull out a positive 1 from 5x and 1. Okay, so now I can go straight into this. 5x plus 1 and x plus 1. And that's my the factored form. Okay, let's just do these last two. So, first step, identify A, B, and C. A is 4, B is -7, and C is -2. So let's multiply A and C, and we're going to put A times C here. So 4 times -2 is -8. And then we're going to put our B term, which is -7. We put our B term down here, so that's -7. So now we have to find a term that multiplies to -8 and adds to -7. So what numbers multiply to -8? -1 times 8. Okay, well 8 minus 1 is +7. So what about 1 times -8? Yeah, 1 times -8 is -8, and 1 minus 8 is -7. So those are our two numbers. And then we're going to write our ax squared term, which was 4x squared. We're going to write that in the first box. And we're going to write c, our constant, we're going to write in the bottom right-hand side. And then we're going to take our two, again, it doesn't matter which order. We're going to put 1 and -8, and then always remember to add on an x. They have to add up to this middle term. So 1x minus 8x is -7x. All right, now we're going to do the GCF. So GCF of this piece. So they have a 4 and an x. So I'm going to help you out here too in terms of, I want to show you something else that I should have showed you up here. Because this makes it easy to check to make sure you took out the right GCF. When you're taking these out, you're actually finding the area of each box. So what I mean by that is, you see this box is 5x squared. What is this side? This side is 5x and this side is x, right? What's x times 5x? That gets you 5x squared, right? What about this box? This box is 5x up here. This is this length is 5x and this length is 1. So 1 times 5x is the inside, 5x. This is x, so we're getting that from over here. This length is x and this length is 1. X times 1 is 1x. And then here, this is 1 and this is 1. So 1 times 1 is 1. So do you see how we're getting each piece of those? We're doing the same thing here. So if you're not sure, I would always check too at the end. Like, we know without even looking that this is going to be an x, because we know now if we took out a 4x here, 4x times x has to equal 4x squared. It has to equal this box. And it actually is an x when we pull out a GCF, because look at these two terms. 4x squared and 1x, the only thing we can pull out from both of these is an x. So you see how that works? So we're actually finding the area of each box. So then if we look here, these two, the only thing we can pull out is a 1. So a positive 1. Right? And that makes sense because this side is x, right? This side is x, this side is 1. 1 times x is 1x. So that should always match. So without even looking at these two numbers, we know this is going to be a -2, because -2 is this length and 1 is this length, and it has to make an area of -2. Well, -2 times 1 is -2. But just to check too, we're going to look here. So -8 and -8x and -2 have a -2 in common, right? It's the greatest common factor, the greatest thing we can pull out of those two numbers. Okay, and then that's it. 4x plus 1 and x minus 2. And that's our final answer. Okay, last one. Identify A, B, and C. A is 6, B is 11, and C is negative 10. The next step, multiply A times C. So 6 times negative 10 is negative 60, and it adds up to 11. Okay, so now you need to find the factors of negative 60. What multiplies to negative 60? Well, we know, let's see, 5 times 12, negative 5 times 12, and 5 times negative 12, but that doesn't add up to 11. What about 6 times 10? 6 times negative 10, and negative 6 times 10, but that doesn't add up to 11. Okay, what about 4 and 15? So let's see, 4 times 15, negative 4 times 15, and then 4 times negative 15. Okay, so it looks like it's negative 4 and 15, right? 15 minus 4 is 11, and negative 4 times 15 is negative 60. Okay. So now we're going to write in ax squared, and our ax squared is 6x squared. And we're going to write in our c, which is negative 10. And then we're going to write, it doesn't matter which order, negative 4x and 15x, because these two always have to add to your middle term, which is a positive 11x. All right, and then we're going to pull out a GCF. So, what's the GCF here? Okay, let's look at 6 and 15 first. What number goes into both of those? A 3, right? That's our GCF. And what about x and x squared? X. Okay. So we know that this one has to be a 2x, right? Because we know that 3 times 2 is 6, and then x times x is x squared, and this has to be the area of 6x squared. And that makes sense, because 6 and negative 4, our greatest common factor is 2. X and x squared, our greatest common factor is x. The only time we pull out a negative, like this I'm going to pull out a negative, is when both of the terms are negative. So I can pull out a negative 2 because these both are negative. Just like, see how I pulled out a negative 2 up here? When we had negative 8 and negative 2, that was the only negative I pulled out. So both of your terms need to be negative to pull out a negative 2, or a negative number. And that makes sense because 2x times negative 2 is negative 4x. And then last piece, we have a positive 5, which makes sense again because 5 times 3x is 15x, and 5 times negative 2 is negative 10. So you see how each piece, each of those boxes, we're taking out, we have to find the same area for each of the boxes. So the area has to match, or you did something wrong. So it's a good way to really do a quick check that way. And that's it.